Good day, Bayaws! Welcome to our YouTube channel, Bayaw Tutorials. In this video, we are going to solve a problem in Chapter 4, Relative Equilibrium of Liquids, from Fluid Mechanics and Hydraulics, 3rd edition by BSABE. So, under certain conditions, the particles of a fluid mass may have no relative motion between each other, yet the mass itself may be in motion. If a mass of fluid is moving with a constant speed or uniform velocity, the conditions are the same as in fluid statics as discussed in previous chapters, but if the body is subjected to acceleration, whether translation or rotation, special treatment is required, and this will be discussed in this chapter. So, here's our problem. 228-C. An open cylindrical vessel 1.2 meter diameter and 2.1 meter depth is 2/3 full of water. If rotated about the vertical axis at constant angular speed of 90 rpm, determine how high is the paraboloid form of the water surface in meters. So here's our given. So the value of our constant angular speed is equals to 90 rpm, and the value of our radius is 0.60. And because the value of our angular speed is equals to 90 rpm, we need to convert it into rod per second. So to convert it, we only need to multiply 90 by 2 times pi r divided by 60, and we get the value 9.42 rad per second. And we are asked to determine how high is the paraboloid. So we're gonna use this formula, y is equals to constant angular speed squared r squared over 2g. And by plugging the given values, we have 9.42 squared times 0.6 squared divided by 2 times 9.81. And by computing this equation, we get the answer for our height, which is equals to 1.63 meters. So, in the question, determine how high is the paraboloid form of the water surface in meters. Our height is equals to 1.63 meter. So, I hope you learned something from this video. Thank you.